Hey everybody, Wes Boss here. This is going to be kind of a cool, different, interesting video. I'm going to be hacking on some hardware. So IBM has sent me this drone and they said, Wes, we'll give you a drone if you make a cool video of you hacking it. And I thought like, cool. I looked up online. I thought like, okay, a lot of people use Python and stuff to program these things, but I'm a JavaScript developer. So I thought that would be pretty cool if I could figure out how to hack this thing or at least run it and fly it with JavaScript. So that's what this video is going to be about. I'm going to attempt to build a Node backend that will power this thing, and I'm going to attempt to make a React front end that will be sort of the controller. And I'm just going to take you along for the ride of me trying to figure out how it all works. It's a little bit outside my wheelhouse. I've done some hardware stuff in the past, so I think it'd be kind of interesting. So IBM is giving 1,500 of these away. If you want to grab one yourself or hopefully win one yourself, you can go to developer.ibm.com/contest. And you can enter in to win one of 1,500 drones. I'm going to talk a little bit more about some of the cool stuff that IBM has and the possibility for the camera on this thing a little bit later on. So here's my thought. This is the Tello documentation. This is it for the entire piece of hardware. So it's a little bit sparse. And I was just reading through it. And it seems like this thing, when you turn it on, you can connect to the Wi-Fi network of the actual drone. And there's kind of three things that get surfaced here. The first one is this sending commands and receiving response. And as far as I played with this on the weekend, I was able to get it up and flip it and set it down. But I said, okay, I can actually control this thing with JavaScript. Let's figure it out from there. So the first one is the actual URL and the port that you can ping this thing, and it will do things like go up, go down, flip, go to the right, go to the left, the whole like controller experience. Then there's another port, which is port 8890. And this will give you the Tello state, which I haven't done yet, but I'm assuming it's going to give you things like roll, tilt, and yaw, which will show you how the tilt of the things. I've done some of that stuff in the past with little hardware projects. And then the third one, which I don't know if we can do in the browser just yet, it's the video stream comes right off this little drone as well. Not sure we're going to be able to get that into the browser just from doing some initial research. But it's certainly something that the documentation shows. There's a couple examples that have done it in Python and desktop software, but it might be something I try if we've got time. So other than that, I'm excited to get started. I'll take you through the actual hardware and some of the things I've found out so far, and then we'll jump right into it. This is the drone itself. It is a Tello. It comes with an extra set of propellers. The entire thing is mostly just one big battery. So if I can pull that out. There it is, and you can charge it on the drone itself, but it's like a 13-minute battery. So once you have run out of battery, then you got to sit around and wait for it to charge. So what I did is I went on Amazon, grabbed this charger, a couple extra batteries, about $100, just so I can continually develop. I have found that it overheats pretty quickly, so sometimes you just need to throw it. I've devised a fan. I just sit it on the fan and let it cool itself down. So that's the hardware. Let's jump into connecting to it. From looking around online, I found this Tello Node.js, which has a couple of examples of how to actually access this thing via Node.js. And the idea here is that you connect to the drone via Wi-Fi, and then you send commands over to this IP address and this port, and then the drone will react to those commands. And the way that you do UDP is you can't do it directly in the browser. There's no low-level networking built into the browser to do that. So you need to use something called dgram on Node.js. This is a standard part of the Node.js library, and it's for sending commands and receiving messages over the UDP protocol. So that's exactly what I'm going to do right now. I'm going to flip open an empty code. I'm going to kind of speed through it. I'll post all my code on GitHub if you want to have a closer look, and then we'll see if we can get this thing to take off and do some flights. Let's run it through real quick. Dgram is the package that we use to interact with UDP on Node. Then I also have this wait package, which will allow us to wait a certain amount of time. That's going to be important because it takes a number of seconds for this drone to take off. The port And the 192.168.10.11, that's when you connect to it via Wi-Fi. You can see I've connected to the Tello via Wi-Fi right here. Then you create a socket connection via UDP4. I call that drone, and you bind it to the port that we're going to be listening on. We listen for any messages that get sent back from the drone via the on message here. And then finally, we have an error handler that we're going to use in just a second. Now, in order to send commands to the drone, let's take a quick look at the documentation that we have here. These are all of the commands that we can send. We can send the command, which is how you enter SDK mode. That's how you know you're a hacker. And then there is takeoff, land, stream on, stream off for video. Emergency, I wish I had coded that in earlier because I just said take off. And then I forgot to actually land the thing, and the program was running, and there was no way for me to stop it. So I had to use a glove and just grab the thing. Up, down, left, right, back, clockwise, counterclockwise, flip, and then a couple other kind of advanced curves where you can make the thing fly around. I'm not sure if I'll get into those. I don't have a whole lot of space in my office here as well. So let's get that up and running. There's another command that you can run, which is called battery, and it'll just tell you where the battery is at. So let's go ahead and do that. So we'll take the drone and we will send the command battery, and you have to put a question mark on the end just because that one command has a question mark on it. And then you have to tell it what's called an offset. If we take a look at the .send method here, you see you send the message, the offset, the length, the port, the address, and the callback, which is going to be my error handler here. So you give it a 0 offset. The length of our command, and this is kind of funny because it's so low level, you have to tell it how big the thing is that you're sending it. So a battery is 1, 2, 3, 4, 5, 6, 7, 8. It's 8 characters long. So we're going to say 8. We are going to send it over the port and the host, and then we have our handle error callback that we have here. It's important to note that UDP is created in such a way where it's not like TCP where you send something and you get a response back. UDP, you just send it. And then via the same connection, they can send stuff back if they want, but you never get a confirmation that that thing was sent properly. So this is not a callback for the response. It's simply just a callback for the thing being successfully sent, or the thing not being successfully sent because of network being down or something like that. So one other thing we need to do is actually send the command first. Otherwise, if you just start sending commands to it without actually being set up in the right place for it, it's not going to accept any of these other commands because it doesn't want to. So we send the command, and then we send the battery command. Let's go here and run that. And the first one, it says okay. That's the response from the command. If we look at the docs here, command, it is either okay or an error. And then back from the battery command, I get 74, which is it's at 74% of the battery. Good. So that's working. Now, what I'm going to do is actually code up a little sequence of takeoff, flip, or turn around or something, and land, or maybe just take off and land. So I'm going to speed up the code again, and I'll meet you back in just a second. Little update we have here. I've imported this command delays. I've grabbed this from the Tello Node.js. There was just a list in here somewhere of how long each of these commands take. So specifically, when you take off, it takes 5 seconds. And when you land, it takes 5 seconds. And you need to give the drone a little bit of time to actually do these things. Otherwise, if you just start hammering it with commands, it'll just ignore them. And because the way UDP works, where it's not going to send you back any information, we don't know if that didn't work. So this delays is very helpful. And I wrote this function called go. It's an async function. First, what we do is we take the first command that we want to send, and then we figure out how long we want to delay that. Then we run the command by saying drone.send. We pass the command, how long it is, the port, the host, and the handle error, just like we did earlier. Then we wait the specific delay that we were talking about earlier. And then if there is still more commands Then we run it again. In our case, actually, we also need to increment the I variables. There we go. And this should be a let because we are going to be incremented it. You could also do this with an async for of loop. That would work just well as well. So I think if we run this now, it should run the command, the battery, take off, and land. I'm going to put this in my room and show you how it's working. It doesn't work because I forgot to run my initial command for the first time. So I run go there. Now let's try it. Okay, 72. There. Land. Beautiful. All right, now what I want to do is figure out, I've done this one, which is the port 8889. I can send commands to it, and it looks like it flies okay. And now I'm questioning, can I get the Tello state from this port 8890? This is something I haven't done yet, so I'm going to flip on the code again and see if I can figure out how to get like a secondary port bound to one of these sockets so I can receive data. So all right, that's what I'm going to try here. I've got the dgram.create socket. So that's another socket called drone state. I'm binding that to a different port. And when that drone state sends us a message, I'm just going to console log it. So let's see if that works. I am going to make some commands here where I don't want to actually fly it every single time that I test it. So I'm just going to run the command and the battery command because it says in the documentation, set up UDP server and listen for a message. Do remark 2 to start receiving state if you haven't. And that remark 2 is send the command. So before you do any of this stuff, you always have to send the command in order to kick it off. So we're just going to send that and ask for the battery percentage and then listen for drone state messages directly from the drone. Let's go ahead and connect to this thing. Whoa! So, oh, look what it's given me there. It's just streaming in the pitch data. See, that's totally flat and the pitch is 0. If I turn it upside down, pitch is 2, 3. Oh, that's pretty cool. So it looks like it gives us, oh, the temp as well. And the tempe. Cool. So what I'm wondering is, can we just take this data and send it to the browser? And something like React is perfect for being able to display all of this information. Before we do that, this is just a one long string. So let's write a little bit of code to split it up based on the semicolon here. So let's stop that and... So what I did here is I made a little function called Parse State. And what that does is it just takes it in, splits it on the semicolon, and then loops over each of those items and splits it on the colon that we have there. And that should give us an array of mini arrays. I could also turn that into an object. Pitch, roll, yaw, temp high, temp low. That's what that, I guess, is for. It's all in the documentation what these different things are. So that's kind of interesting as well. It tells me the battery value as well in the drone state, which is kind of cool. One thing I did notice, though, is I just tried to run it and it just dumped buffers on me and not strings. And the reason is because previously we had been console logging the message inside of a string. And then in here, I'm just console logging the state directly. And that gives me a buffer. And the reason is because when you put a buffer into a string, it calls the .toString method on the buffer, and that will then convert it into a string for us. So what I need to do is pass this as .toString, and then I'm going to just pass it to my parse state and console log the actual formatted state. So let's try that again. There we go. Every time I run it, now I'm getting the actual values straight from the drone itself. they're being put on. I got a new line there at the bottom there. Not a big deal. I can filter that out as well. So now's the question, how do I get this data from my Node app that I just built and hacked together here into the browser? Because now it's just raw data. We need something that will both send commands from the browser to the backend, which will then relay them to the drone, as well as when the data comes from the drone to the backend, send that data to the browser. And a perfect use case for that is WebSockets. I really like WebSockets because they are instant. They don't have the overhead of opening up a request, pinging the backend, and coming back. It's just sort of this pipeline. It's a socket. It's much like the socket that we have connecting our UDP socket to this thing, but it's for the web. So we're simply just going to relay the data from the drone to the browser via WebSocket, and the commands from the browser to the drone via a WebSocket as well. So I'm going to hack together a little React application and get Socket.io hooked up, and then I'll come back and explain how everything has gone. All right, so I just whipped up a quick little Next.js React application here. I just have an index page that says I am a page. I'll take that out actually. And then I have the drone state and the commands. Those are the two things that we've looked at so far. I am going to attempt to get the drone state to pull in first, because I think that's simplest. And then we will look at the commands being able to send the data from these commands to the backend. Now, in order to do that, we need to jump back into our backend now and set up a Socket.io. Socket.io is probably the easiest way to get WebSockets set up. I probably think in any language, and it's made for Node. So I'm going to flip over to my backend and start coding up a WebSocket, and then we'll flip back to our front end and code up Socket.io that will allow us to intercept and accept those messages. All right, so what I just did there is I took out our go command that we are using to send commands to it, because I just comment that out for just a second. And then I went up to the top here and I imported Express, which is our web server. I imported the HTTP library and passed it our Express instance that we have. And then we are also creating a new Socket.io instance on that existing server that we have, which is great. Then we go down to the bottom here and we listen for the Socket.io connection, which is when our WebSocket is being connected to from a front end. We will emit a status of connected, and we are going to be listening for commands from the browser. This is very simple, nothing hooked up to the drone just yet. I wanted to make sure that we can get data flowing from the front end to the back end. Finally, we take that server and we listen on port 6767. And if that worked properly, we should be able to go to localhost 6767 /socket.io /socket.io.js. And we do, and that shows us this is the Socket.io library, which we need to connect to on our client side. So let's flip back over to the client side now, and I'm going to hook up. Let's go into the drone state and let's hook up the Socket.io as well. All right, so what I just did here is I created a socket.js. So you import IO from this thing here. You create your socket, which connects to our backend. This is the URL for our backend right here. And then I export that socket. And then anywhere I need to use that socket, I simply just import it right here. Here I've made a little React hook. I'm not sure if this is the best way to use hooks, so don't take this as gospel. I'm still new to this stuff with React hooks, but I am using React state here to set the status of default to disconnected. And then we also destructured this update status function in here. Then we listen for a status to be sent from the backend. Remember, if we jump into our backend here, we socket.emit status of connected. So when something like this gets emitted from the backend, we listen to it on the front end with on status, and we are console logging a message from socket, and then updating the status with what's being sent from the backend. That's pretty cool. And then that will then in turn update the state, and I should be able to show it. So connected, if I refresh real quick, we see disconnected and then connected. If I were to go on the back end here, and I don't know, maybe after like set timeout of 2 seconds, we were to emit another one of like a poop, and we were to restart that server. Disconnected, connected. 2 seconds later, you see that the emoji. So any status that's getting sent from the back end will obviously be gobbled up by the front end, and we can then display that data. So what I want to do now is figure out how do we use our drone state on a message to then send this data to the front end. All right, I've got this thing working now. A little bit of trouble with React hooks because I'm new to this stuff, and seems to be working just fine now. So what's happening is the data is flying off the drone. We're sending that over the WebSocket. That's then being set to state in React, and I'm just dumping it onto the page. We'll format it a little bit nicer. So let me show you 2 problems that I ran into and how I solved them. The first was that the info here flies off of this thing, and it's just like, it's almost too much data. It is too much data. It's just a fire hose of data that's coming off, and we don't want to send all of that to the browser. It's unnecessary to update it that frequently. So what I did on the back end here is I listened to the drone for a message, and then we run the emit command here, but I wrap that entire function here in a throttle from Lodash, and that will run this update and emit at most once every 100 milliseconds. And that's more than enough data that we actually need. The rest just gets thrown out. So that's good. We can go ahead and remove that console log there. The other problem I had was with React hooks. So I made this custom hook here called use socket and use drone state. And these little hooks ourselves have internal React state, as well as do what's called a side effect, which a side effect is like when you go off and listen for something outside of the pure component. And here what we're doing is we're listening for drone state updates and a status from the backend. Now, what I forgot to do is I forgot to pass this little second argument to use effect, which tells it to rerun this effect. Because you might be saying like, okay, well, this drone state here, when we run this function, does that mean that this use effect runs every re-render? And use effect knows not to rerun itself unless its dependencies right here have changed. And by deleting that or not putting it there, I accidentally was listening every single re-render. I was re-listening for socket.on drone state, and what that was doing is it was causing hundreds and hundreds of event listeners with. Combined with the other issue I had, thousands of pieces of data flying in, and I left it for 20 seconds and it had like 200,000 console logs, and the browser froze. So I throttled it on the back end, and obviously I'm not only going to listen for the socket once, unless any dependency, which in our case we have no dependency of this thing, which is just an empty array. I did the same thing for our socket as well. Even though it wasn't causing us an issue there, we could run out of memory, and which is what happened there. Now, next thing I want to do is be able to send these values here. When I click on one of them, here, let me just get these console.logs out of here. And I want to be able to click on these and send that data to the backend. So if we go to commands.js, I already have a function here that just console logs sending the command. These are some of the different commands that we want to have. flip, land, back, forward, left. We should probably put another emergency one. Emergency. Now I'm going to attempt to get everything up and running with the data sending from the browser to the WebSocket and then relay that to the actual drone. So I'll catch up with you in just a second. All right, I am listening to the socket for a command. I am seeing in my terminal when I actually send a command, it says command sent from browser, left 20. So I think if I click on takeoff, it should take off. Let's see. And so down 20 centimeters, up 20 centimeters. Let's try flip. Ready? Oh, that's fun. And land. It